Hello there. This is Al, and today is October 2nd, and this is a continuation of the NT series, number 4. And the last one was about deciphering jargon. And I have deciphered quite a lot more, and I'd like to get to telling you about it. I also want to mention, as far as the other tutorial goes, I haven't forgotten about it. In fact, I do have another project I'm looking at in the works. My only problem is, now see, this is something I could go through and from sort of start to finish. It's a program that I want to write. It basically does this, inside a command box, same interface, everything. Because I would like a Win32 version of that doesn't do this, for instance. And so there's that. Now that kind of program, the reason I've done a lot of work on it, and already written a whole bunch of classes, and I'm trying to decide just how much work would go into a project like that. If you've ever tried to write an editor, even a simple one-line editor is an extremely difficult task to do. Drawing the box and the menus and everything, that's nothing. But editing is really tricky business, and so I don't know. It might be more work than it's worth. So that's why I haven't decided yet if I'm going to continue on with this project. Now, as far as for what I've learned, some of the words now are starting to make a lot of sense. In fact, much more sense than I had expected they would. Now, it's hard for me to find these things. Now, where did that one come from? When speaking about security descriptors, somewhere in here, it said that there were two formats. One was called self-relative, and I remember where were we reading that? Was it in here? Must have been, or somewhere. See, this relative identifier thing, I understand that now, and I don't want to get to that. There's nothing to that. But there was something called self-relative. Now, I know where to look at the definition, but I can't remember where it was referred. Where did it come up? Here, maybe? It would have to have been. It had to have been in the context of a security descriptor, which was the thing that we were looking at, that security descriptor definition language, but that came from somewhere else, and I can't remember. This is actually, I might want to keep, or this is the code I already copied. Okay. I should go look at the other video. At some point, it said that sometimes a security descriptor is self-relative, right? So a security descriptor can be in either absolute or self-relative format. And wherever it was, I said, now this is where the language, the English language and the analogy appear to differ. But maybe I'm wrong, I thought. But in fact, I was wrong. What? Didn't I just click on self-relative? Oh, yeah. The surprising description, which isn't so surprising anymore, actually makes perfect sense. And the way in which it makes perfect sense is something that I discussed a long time ago, back in the C++ tutorial, having to do with what I called something that is relocatable. Okay, and I had this block of code that I had that dumped out some text, and I said that code was relocatable. And the reason that piece of code was relocatable was because all of its offsets were relative. Okay? Now they don't say that explicitly here, but the fact is, a self-relative, in self-relative format, a security descriptor stores something called a security descriptor structure and associated information in one contiguous block of memory. Okay? So that means that all information pertaining to that descriptor is at a relative offset with respect to that particular security descriptor. That is, all information about that security descriptor can be written as an offset relative to itself. So it's self-relative. See? Whereas an absolute security descriptor, although containing similar information, does not store the information in one chunk. It only stores pointers to the information. And in an analogous way, an absolute security descriptor is not relocatable, whereas a self-relative one is relocatable in the same sense in which I spoke about it in the DOS scenario. And in this case, what I mean by relocatable isn't that you can't move that file from one directory to another, but that you wouldn't be able to transfer it to a CD or copy it over the internet or something and have it retain its security it's secure, the security element that is associated with it. Some types of documents do contain their own security descriptors. Some PDF files you can't open, so on. And those would have to be self-relative descriptors. So that now makes perfect sense. I thought those words were weird, but in fact it's not weird at all. Another thing I thought was surprising was, what was the other word I thought was surprising? Oh, well, no, we discussed that. That was the system access control list, which had to do with auditing. In the last video, I mentioned, and I said I would mention at the head of this video, in case people don't watch to the end, was the other. I mentioned what I called Microsoft's other major client. That is one client that Microsoft has that I had forgotten, or I just overlooked, and when I talked about what I thought were two major clients. But they do have a third major client, and that third major client comes up almost immediately. In fact, it comes up in the first link here under access control. And that third client is the U.S. government, and in particular the U.S. Department of Defense, who have defined for themselves whatever the two here is, I don't know, maybe that's second level security, and what constitutes C2 level security, and these bulleted requirements. So they don't say it explicitly here. You can see this article is everything's implied here, right? First they list a whole bunch of things that are essentially implemented in the security system for, I'm calling it NT, but they call it, they have a different word. And then they say that it's not supported for basically DOS Windows, and then stop. Nothing else. Just thought I'd mention that just so happens it's not supported for these operating systems. Okay, now back to talking about security. Yeah, so obviously the one of Microsoft's important clients is the U.S. Department of Defense, and a lot of the wackiness involved in this system is attributable to the requests being issued by that particular client, mostly to do with things like auditing and control of auditing messages, which is the way it's demanded back in that article. Is that the audit security-related events should be auditable, and the access to such events has to be limited to only certain authorized individuals, and they ought to be able to audit, which normally means to hear. But in this context, it also means to make a record. So basically, it is a request for the the power of what I call the power of what did I call it? Deniability. If system administrators are able to audit and access and exclusively have this ability, then they have the ability to control the record, basically the records, the accounts, what's occurred in the system in total. And they can modify that any way they like because they have the access is exclusive, and so that gives them the power of deniability, which is something that all secure systems, organizations as well, expect to have. It's normal whenever if an organization is being taken to court for having broken some law, and it looks like they're all all the top guys are going to get 10 years in slammer. The first step is they get a shredding machine, and the secretary sits there all day and just shreds all the documents. So that they can deny things in court, and so that there won't be proof of whatever they've been accused of, or at least enough proof to, put them away for a longer period of time. So that's security. That's part of security. Now, now I'm in a list. Oops. I wanted to try and do this in a certain order. I mentioned that. So now I know what self-relative and absolute means. Now, RID. Now I read I think I just simply read it wrong. I was saying and thinking that a relative identifier was something to do with an authority, right? If you reread go back and reread it, if I can find it. How do I get there? How do I get there? Where was that? Relative authority. Oh yeah, it certainly comes up in here. SID components. The components that make up a security identifier: the issuing authority number, which is a 6-byte value, and then followed by a variable number of sub-authority or relative identifier values that uniquely blah blah blah. And remember that although I can't seem to click, well I can click right from here. We looked it up here and it looked like there was a contradiction. Right? This says the portion of the identifier, and whereas this says a variable number of this or that, right? And it is slightly contradictory, but in as far as the definitions go, but in practice, they're both correct. Now, See, it depends on how you read this, okay? Some people would say, this is an ambiguity in English. I don't know what particular brand this is, but there are two ways to interpret the sentence, right? It says a variable number of x. Now the or here could be another way of saying x. Like I might say, there were a number of SIDs or security identifiers or something like that, like restating in different words the same thing. Or it could mean that it's either this or this, where these two things are not the same. Now, I have proven that they are not the same, and I have proven that because I have come to an understanding. I've come to understand and read correctly another sentence, this one, wherein they outline why it is that these security identifier strings must be unique, at least within a certain range. Maybe not the same. Maybe on another machine, another user could have my security identifier string, but not on this machine. And that's true because first what I did was I created another user and I printed out the new user's security identifier string. And you shall notice this is a revision number. This is the issuing authority, okay? Happens to be NV authority. This here is a well-known authority, which is something to do with non-unique something or other. Security non-unique, something like that. Now you will notice that these numbers, that all of these numbers, all the way up to here, are exactly the same. The only difference in these two strings, if you look at it as groups of numbers delimited by dashes, is the last two numbers. Okay? Now, I've also written this down here. Taking them at their word, each SID issuing authority issues a given relative identifier, a given relative identifier only once. This is a given relative identifier. How do I know that? Because these things, I know everything now, because since these are all the same, and it says that a SID issuing authority issues a given relative authority identifier, only once, none of these can be RIDs, because this is the same issuing authority. So these must all be sub-authorities. They have to be. They can't be RIDs because it only issues RIDs, given RIDs, once. So this last bit, the single bit, trailing number, is the one and only relative identifier that has been issued by this issuing agent. Okay? Now, of course, this is, again, would be within some context. Now, assuming that there were another security identifier issuing agent or authority on my system, its identifier number would appear in my security identifier string and whatever other strings it generates. So therefore, this part of its string, maybe 6, let's say, would not match with any of these strings, right? So by definition, any other security identifier issuing authority issued SID number values must differ from the ones being issued from this one, from 5, because they'll have a 6 here. So those are all unique, but also within the group of the set of SIDs issued by 5, those are also unique because it will only issue at most once any given relative identifier. So you'll never see another 1005. In fact, you could, and I've done that before. There's a place in the registry where it stores the next number, and you can modify that. But anyway, okay, so therefore now I understand that sentence, and I understand that none of these are ID values, and so there is only one RID value in this security identifier string, and that's this number, and therefore it is the RID, the part of the string that identifies this trustee with this authority. Okay. Now it also follows. It's also an interesting twist that I noticed in winnt.h that there's a number defined called SID recommended sub-authorities, okay, which these are all called sub-authorities, even if the last one is not a sub-authority. For some reason, when you retrieve these numbers, you call a function that's called get next sub-authority or something. However, so one RID was issued, and and I believe that the reason only one got issued is because it is using this recommendation for the issuing, and it says here in a comment in the same file that this number will increase to 6, and maybe it has in some other release. So I don't know what your SID strings look like, but you might have 6 relative identifier numbers that uniquely identify you with respect to your authority, the issuing agent. All right. Check my time. Okay. Now the problem, if you recall, one of the problems was the fact that there was this function that removed access from a directory and we couldn't get it back. And the reason it's a function that used to work before and then it stopped working. Now somehow, almost by random chance, I actually found a function that can retrieve the actual security descriptor. I'm not talking about any access control lists or anything like that, for a file or directory using only the path name. That means you don't have to get a handle to that object. The reason I couldn't do anything with it after it had been locked was because I couldn't get a handle to that object, that directory, when I was trying to give the access back. I found a function that retrieves just the descriptor, which is, although the descriptor is sort of part of the object, it needs to be able to be read in order for me to find out whether or not I can access that thing. And so you can always access, at least read the descriptor. You can also write to it. And so then I used that function and I found a way to retrieve so now I have a way to retrieve the descriptor and modify it without having to open the path. Now, therefore no handle was required. And that's when I realized about this self-relative thing, because the security descriptor that's returned to you by that function is not a reference or anything. It's a full copy of the security descriptor in one contiguous block of memory. They don't say that explicitly. They say it returns it in self-relative format. Okay. Now the function, it's just I just randomly looked in here, and because I was actually trying to find just any way to have a look at a security descriptor, just see what one looks like. And then I clicked on this. I didn't think it would be of any use, Get file security. Huh? Oh, it returns a security descriptor. And the part of the descriptor that you want in particular. Like I want the discretionary access control list, and it'll return not only, it'll return to me a security descriptor structure containing, at least the parts of it that I want. Okay? And the returned thing, it says it's got to say it somewhere in here. Here. The structure is returned in self-relative format. Well, so now, I thought, the reason why it dawned on me that this was a good thing, the reason why this explained to me exactly what self-relative means and why it's exactly the right word, is because when you just read this line, pointer to a buffer that receives a copy of the security descriptor of the object in self-relative format, right? So that means it contains all of the data, as well as the flags and things. And that also means that when I extract, if I extract something out of this, like there's a function, there are functions to retrieve things from a security descriptor. Or is it like I wanted to get the DACL out? What was that function called? Gotta be careful, you lose yourself here. Here. No, I can't read it. This has a handle. That's what I was using. That's no good. Come on, which one? Well, maybe I can see. I didn't delete all of the code. No, I deleted most of it. Okay, get security DACL. Now, see, now this one I needed to allocate memory, but I had to switch methods. That's the problem. But no, yeah, no. See, this returns a security descriptor struct, and before I went on to doing what I'm doing here, which is turning it back into an absolute security descriptor, there was a function I was calling to get the list out of the descriptor, and I knew that I would not have to allocate any buffer for that because it's self-contained, and it's not listed in here anymore in the history. Which one's which? This is source A. Yeah, oh, I guess that was it. Get security DACL, right? And it takes some pointers, a pointer to a pointer. And I know I don't have to free that pointer because if I'm going to free anything, it's just the thing that I already malloc, the security descriptor. But it turns out that that was no good because in the end, the function that you need to use in order to apply not that function. The function that you need to use in order to modify one of those discretionary access control lists, okay, expects the security descriptor, the thing to be modified, to be in absolute format. And so now that doesn't mean it's going to copy the pointers or anything, right? The pointers are it just wants it in that format for whatever reason. So I've got to allocate a whole bunch of pointers now to take all the data I already have allocated memory for and split it up, making it into an absolute security descriptor with all these reallocs. in order to modify the one piece of the descriptor I want to modify. And worse than that, this make absolute security descriptor from relative function won't let me just ask for a piece of it. It's got to be the whole thing. So you got to pass valid pointers for every possible sub-component of a security descriptor. And now I know what all those components are, though, because this thing forced me to write them down. There is the discretionary access control list, the system access control list, the owner, and it's that's a security identifier string. It may not be stored as a string. It's not actually. It's stored as an SID identifier, not as a string. So that's the binary format. And the group. So it has an owner. This group is the default, what's called the default group. It was too much to type in, but if you F1 on this one, oh sorry, primary, I should probably type it in. That's the primary group. This is a member of, I guess. Now these fields were empty, turns out, but it did have that system ACL, and it had a discretionary ACL, and so that worked. Now I've gone on too long, but let me just tell you that although I was able to regain control of that directory, it had a completely messed up security descriptor, or at least the discretionary list. The DACL, its DACL was messed up. Because the only way I could get it back essentially was to delete the whole thing and just grant access, explicit access to the user's group, and it ended up left with just one entry in the list, users, with explicit access for everything, right? Because what I now know that what I was doing was wrong. Every time you add one of these access control entries to a list, it adds a new entry to the list. You know, so to block and then give back, I do the same thing. I add an explicit access. Hello? I'm fine, no problem. Don't worry about it. Sorry about that. Now where was I? Yeah, so that list was completely messed up. I had added 2 extra entries, both with only explicit values, like the dark check marks, 1 explicit access, 1 explicit denial, and it reads the denials first, and so you still couldn't access it. It must be that in XP it always adds things at the head of the list, adds the explicit access entries at the head of the list, and so therefore the explicit granting of access overrode the refusal. but now it doesn't do that anymore. They fixed that bug, and the denial always comes up first. So I had to delete the whole thing and replace it with that's what I have here. The source ACL list is to be null merged with one explicit access entry, which is a generic all for the group users. And that's one messed up list. It's not doing what it's supposed to, which is to restore the list back to what it originally was. What I wanted to do was remove those explicit denials, not add a new entry. So although I've found a way of at least not losing control of the file, I still have to repair the function so that it works properly and doesn't do those wrong things. But now that I understand more, and the understanding has come largely from just learning the vocabulary, I understand now. I have discovered, at least, that my function wasn't working right. It was doing wrong things. And that I need to know those things, and that's why it's imperative for me to learn this language. What else did I find out? Well, there's something I found out about, but it's related to security, and it's something that I want to address. It's a type of, I saw this video, and in the video, it's about a lib you can download that can pretty much apply system-wide overrides in a very easy way, so that it's a very dangerous thing, and it would be difficult to detect its presence on your system, and people could write code that uses this lib, and you don't really need to know very much, almost nothing, in order to use it. So I wanted to add another thing to this access function set detection for that particular type of hooking. On my system, I have no way to tell if there's hidden software running on my system, or hidden monitors monitoring the actions that I do. It could be there, and there's no way to see it except to actually look at the assembler code that gets called, and look for a particular signature. Okay, well, that's all for now. See you.